potential difference. What idea do you have by voltage? Do you have an idea?
Potential reference?
Potential difference.
Difference.
What can this mean? Current we knew, so that's a number of electrons that move per second.
It's the power of current.
If the voltage is high, the consuming of current is more.
The power of current, yeah, it comes close.
The charge of
But
the current.
power is something special. That's if you stick to power, then you can calculate power by multiplying voltage times current.
Yeah.
So within that we can extract voltage.
It's the
But
charge.
this is just a mathematical clue. It doesn't give you any physical understanding of the thing. So what is voltage? Voltage, if you're thinking about voltage, the best thing you can think about is
We can say
a rechargeable battery. What do you
we
have?
can say it's potential energy per unit charge.
Potential energy per unit charge, yeah? That's exactly what you're doing if you think about recharging a battery, yeah? So maybe you have a battery of 1 volt and you would like to recharge this battery. So then maybe it's used in your mobile phone. You can use it sometimes and then it's flat and you have to recharge the battery. So how can you recharge a battery? The thing you can do is, this maybe it's an electron pump. So this thing here, it's also a thought experiment, an electron pump. But the normal battery is very close to that, it's an electron pump. And maybe think about pumping the electron in this direction. Then, if it's a 1 volt battery, you can say the voltage that is developing across this battery is the energy or the work you have to put into that pump to pump the electrons divided by the number of charge carriers you pump, divided by the charge. So it's the work you put in divided by the charge you pump. So the charge the charge are the electrons you pump from one end to the other. Yeah? So that's more or less the same like potential energy. So it's the work divided by the charge you have pumped. And the charge are the number of charge carriers. Yeah? And then you had put the work into the battery, and then you can remove the battery from your charger and put it again in your cell phone, and you can use the work that the pump has done on this battery. So that's the idea of volt. Voltage is always work divided by charge, or potential energy, that's the same. Huh? But that's the other way around the potential energy. Yeah?
Excuse me, but this is not exactly false example, because we have, for example, if we use a battery with an armature, which can move, but if we make this movement vice versa, so the battery will charge. The basics of getting of generators, I think.
Yeah. After that, after you have pumped the electrons from one side to the other, so the important point is the difference between a flat battery and a recharged battery, there are always the same number of electrons in the battery. Yeah, maybe think about the battery, yeah? This here. You have a division here. Let's say one side is the positive, the other one is the negative. Let's say if you got 1000 electrons on this side and you got 0 electrons on the other side, maybe we have pumped all the electrons from here to the other side with our electron pumps. Huh? Then we have put in some work because we have to drive the pump. And if this is running for, I don't know, a couple of seconds, then we have pumped all the electrons to the other side. Then the battery is charged. We say that the battery is charged. We can use this battery in our external circuit, in our cell phone, whatever. We connect here our load, and then the electrons, since we got a lot of electrons on this side, will move to the other side. Because there is an external circuit where the electron difference can flatten out. And what will happen? You will not see 1000 electrons at the other side and 0 here. What you will see is you've got 500 electrons here, 500 electrons here. Then there is no motivation for the electrons to go on here, yeah? Because that's the same intensity or same distribution of electrons on both sides. Now the battery is flat. Huh? And if you got an accumulator, you can again put in your electron pump here and pump the electrons from this side to the other side to regain this state here. Huh? But if the battery is charged, then you can put a motor here or whatever, a load. And this load means that the electron difference is flattened out. So that's it. But nevertheless, within the battery, you will always have 1000 electrons. Huh? So the electrons is not disappearing from the battery, it's just flattening out to both sides.
So the voltage is the work done to set up the potential difference between the battery.
Exactly. That's the voltage. How much work do you have to put in here to get the electrons from one to the other side? Huh? And for a 9-volt battery, it takes more energy to pump the electron from one side to the other than for a 1-volt battery. Yeah? And the same do you have from a 9-volt battery. You can draw a higher current with the same load as from a 1-volt battery. Yeah? And the work you can draw from a battery, since the power the battery can supply to your load, let's say now we have an understanding of voltage, and if we have an understanding of voltage, then we can understand a battery. If you are buying a battery, what does it say on the battery?
9 volts or something.
Let's say, for example, 9 volts. Huh? Maybe you buy your battery, it says 9 volts. But a normal battery doesn't give you more information like that. Yeah? It's just 9 volts. That means if you, let's say we have a bulb here, it's a 9-volt bulb, otherwise it will explode. Then maybe, let's say there's a current flowing of 1 amp. Then we can calculate the power that the battery is delivering to the bulb by a simple equation, that's Joule's law. It's voltage times current. So it's 9 volts times 1 amp gives you 9 watts. So then this battery gives you a power, a maximum, at the current of 1 amp, a maximum power of 9 watts. And if you're thinking what what work can this battery produce, then you have to multiply it with the time. Since the work is power times time. So, and the work that we have stored in this battery is more or less the same that you can draw from this battery afterwards. Huh? So that's the work that the battery can give you. It's the same amount of work that you have stored in that battery during charging. But normally it's not the same numbers. You got some power dissipation, so the efficiency is not 100% between charging and recharging. Yeah? But at least this gives you an idea. And then we nearly have all our components for an electronic circuit. We knew what is current, we knew what is voltage. And there is one property left. These are the connections. The connections. We have to characterize our connections. That's the last point before we can go to an example.